Michio Kaku's famous perception right into a surprising revelation. The James Webb Space Telescope has recognized a demanding sign transmitting from the Andromeda cosmic system for north of a century. How we would interpret Andromeda changed into commonly terrestrial, but at this point, outfitted with the James Webb Space Telescope, our viewpoints are decisively shifting. This new record has sent shockwaves through established researchers, but what does this beautiful revelation inform us? And for what motive is it growing such a ruckus amongst area specialists? Join us as we delve into the subtleties of this disclosure and explore the way it affects how we would interpret our adjoining universe. Before we dig into the details of the demanding sign, it's enormous to peer a few context about the Andromeda International. Commonly, the Andromeda universe turned into the first hint that our universe extends beyond the Milky Way. This revelation shifted our expertise, highlighting that we may additionally just be a small piece of a full-size universe. Initially, the Milky Way becomes seen because the entire of the universe. Early cosmologists, the use of restrained era, could not separate the Milky Way into character stars. This changed with Galileo Galilei within the 17th century. Using a telescope, he discovered that the Milky Way was comprised of numerous stars. This locating started out to challenge the concept that the Milky Way changed into the universe's only global. The real game-changer came with Edwin Hubble throughout the 20s. Using the Hubble telescope, he noticed distant objects past the Milky Way, figuring out those as separate galaxies, expanding our view of the universe. One of such galaxies was Andromeda, also called M31. Its observation dates again to the Persian astronomer Abi Alaman Alfai inside the 10th century, who noted it without the aid of telescopic generation. Through the 20th century, technological improvements allowed astronomers to explore further. They understood that Andromeda was an indistinct cloud with a giant universe of stars, just like our Milky Way but located around 2.5 million light-years away. The look at of Andromeda has evolved drastically due to the fact that observations have shifted from ground-based telescopes to space observatories like the Hubble and presently the James Webb Space Telescope. Each new device has brought us in the direction of understanding Andromeda's actual essence. Decoding Andromeda's layout and agency facilitates astronomers delve deeper into the universe. It serves as a benchmark for our Milky Way, offering insights into the structure's development and evolution. The relationship between the two galaxies is important for expertise the fate of our Milky Way, especially because they're expected to collide in around 4 billion years. Recently, the James Webb Telescope has obtained a worrying signal from the Andromeda Galaxy. The telescope's strong sensors have detected uncommon hobby in Andromeda's center, varying significantly from beyond observations. One key locating is the change in Andromeda's mass. Estimates said Andromeda become considerably larger than the Milky Way, but new information indicates this gap may additionally not be as great as previously notion. Updated measurements indicate that Andromeda and the Milky Way are more comparable in size, reshaping how we might interpret our galaxy's area. Additionally, the James Webb Telescope has furnished clear photographs and spectra from Andromeda. These have revealed new famous person formations and chemical compositions within the galaxy. Such info is important for expertise how galaxies evolve and what situations should cause lifestyles. Another big discovery includes Andromeda's energetic cosmic center. The information suggests that the black hole at the middle is more lively than formerly believed. This activity impacts the encircling location and can influence the galaxy's overall shape and future. The telescope's findings additionally touch on the mysterious darkish depend. By reading the gravitational outcomes on Andromeda stars, researchers can better recognize how darkish depend is allotted throughout the universe. These new discoveries through the James Webb Telescope have brought about diverse studies. Scientists worldwide are reading the statistics to find greater approximately Andromeda's secrets. Every finding facilitates piece collectively the galaxy's history and destiny, presenting a clearer expertise of the universe's workings. Andromeda, our nearest cosmic neighbor, has a variety of specific features that interest astronomers and set it aside from other galaxies. Firstly, Andromeda's size is vast. Recent information suggests it spans around 220,000 light-years in diameter, making it one of the largest galaxies within the nearby group, much larger than the Milky Way. Its enormous size contributes to its mass, holding an estimated 1 trillion stars, surpassing the number in our own galaxy. Andromeda's shape is another point of interest. It has a typical spiral shape but with a bulge. The galaxy consists of a bulging center surrounded by rings of dust and gas, which are sites of active star formation. These features suggest a vibrant galaxy with ongoing processes that shape its appearance and evolution. The core of Andromeda is particularly thrilling due to the presence of a double-capped outflow, suggesting it can harbor a very large black hole. Moreover, Andromeda is surrounded by a corona of celestial fabric extending millions of light-years. This corona consists of stars, planetary nebulae, and globular clusters, providing evidence of the galaxy's complex evolution and history. The globular clusters, particularly, are of enormous hobby. With more than 460 diagnosed, they provide insights into the early stages of the universe's development and the dynamics of superstar clusters. Another particular aspect of Andromeda is its satellite galaxies. More than 20 smaller galaxies orbit Andromeda, some of which are being tidally stripped of their stars and gas, contributing to Andromeda's growth. This process, called galactic cannibalism, highlights the aggressive nature of galaxy evolution and provides a live example of how galaxies develop and interact over time. The evolution and destiny of the Andromeda Galaxy are subjects of sizable interest and studies in astronomy. One massive aspect of Andromeda's evolution is its potential transition from a spiral to a ring galaxy. Observations suggest adjustments inside the pattern could cause this uncommon shape. Ring galaxies are rare and shape below unique situations, often after a collision or close to miss with another galaxy. If Andromeda is evolving into this structure, it suggests a history involving interactions with other galaxies. Andromeda's destiny is closely tied to its interaction with the Milky Way. Estimates expect that in around 4 billion years, Andromeda and the Milky Way will collide and merge. This event, while seemingly catastrophic, is a natural part of cosmic evolution. The collision will not involve direct collisions among stars due to the enormous distances between them. However, the gravitational forces will reshape both galaxies throughout the merger. Gas and dust from both galaxies will interact, leading to new bursts of star formation. This burst of celestial creation will illuminate the merging galaxies, creating a unique and stunning cosmic event. Changes in Earth's orbit or axis could also disrupt the distribution of ecosystems across the globe. Some species could thrive under these new situations, while others could face extinction. Moreover, the merger may also cause new star formation as gas clouds from both galaxies collide and compress. If this famous person formation occurs close to the planetary device, the radiation from these new stars should also have an effect on Earth's surroundings, further influencing weather and existence. But it is important to be aware that those occasions are projected to arise billions of years inside the destiny. Human life as we comprehend it may additionally have advanced significantly by then, or our species could inhabit one-of-a-kind components of the galaxy or universe. The findings from the Andromeda Galaxy have considerable implications for expertise our galaxy and its destiny. The evaluation among Andromeda and the Milky Way enables astronomers better recognize the shape and evolution of spiral galaxies. Observing Andromeda's dynamics, such as its spiral arms and the interest around its brilliant massive black hole, presents a reference factor to cognizance on similar capabilities inside the Milky Way. This comparative look refines our models of cosmic dynamics and evolution. Moreover, the invention of Andromeda's length and mass has direct implications for how we interpret the Milky Way. Initial assumptions said Andromeda becomes significantly larger than the Milky Way. However, recent information suggests that the galaxies may be more similar in size than previously thought, challenging our attitude on the Milky Way's function inside the nearby group of galaxies and its gravitational influence. Although the Milky Way is currently a B-spiral galaxy, interactions with neighboring galaxies, particularly Andromeda, could change its shape. Understanding Andromeda's evolution affords clues approximately the activities that lead to such massive modifications in galaxy morphology. By that specialize in Andromeda's present-day status and predicting its future trajectory, astronomers can simulate the outcomes on the Milky Way, including changes in star formation, the distribution of gas and dirt, and the dynamics of each galactic horus. The sector of astronomy has skilled significant changes thanks to technological advancements. From the earliest telescopes to the sophisticated observatories of nowadays, each step forward has elevated our information of space. The journey commenced with the invention of the telescope inside the early 17th century. This easy tool, including lenses inside a tube, allowed astronomers to have a look at the moons of Jupiter and the stages of Venus. Over time, so did the complexity and strength of telescopes. The 19th and early 20th centuries saw the development of large, more powerful telescopes. These allowed astronomers to see in addition into space and to discover new celestial bodies, including Neptune. But these ground-primarily based telescopes had obstacles, especially due to atmospheric interference and mild pollution. The launch of the Hubble Space Telescope in 1990 marked a significant jump forward. Positioned above Earth's ecosystem, Hubble furnished clearer, deeper views of the universe than ever before. Its observations have brought about breakthroughs in how we interpret dark count, the age of the universe, and the evolution of space. Following Hubble, different space telescopes consisting of the Chandra X-ray Observatory and the Spitzer Space Telescope have discovered the universe from space. In addition to optical telescopes, radio, infrared, and X-ray observatories have extended our cosmic toolkit. These units allow astronomers to hit upon and study phenomena, which include the universe's microwave historical past radiation, star formation areas, and the remnants of supernova explosions. Dark be counted remains one of the universe's biggest mysteries, invisible but comprising a sizable portion of a galaxy's Massachusetts dark, does not emit, absorb, or replicate mild, making it invisible by conventional methods. Rather, its existence is inferred from gravitation consequences on visible remember radiation and the big-scale structure of the universe. In Andromeda, evidence for dark count number comes from the galaxy's rotational pace. Stars near the galaxy's facet rotate at similar speeds to those near the middle, contrary to what would be expected if best visible count had been gift. This uniform rotation charge suggests a sizable quantity of unseen mass attributed to dark matter enveloping and influencing the galaxy. Observations of Andromeda also screen a huge halo of darkish matter extending a ways beyond the visible stars. This halo affects the motion of satellite galaxies and big-name clusters orbiting Andromeda. By that specialize in those orbital motions, astronomers can estimate the mass and distribution of dark count number inside the galaxy. Such studies suggest that Andromeda's dark count number halo is each large and significant, extending north of 1 million miles from its middle. The distribution of dark count in Andromeda isn't uniform. It is denser near the galaxy's center and turns into less dense outward. This distribution impacts the formation and evolution of stars and fuel clouds inside the galaxy. Dark depends gravitational pull helps form the spiral hands and affects the charge and location of latest megastar formation. Moreover, dark matter is believed to play a huge function in cosmic collisions and mergers. The anticipated collision between Andromeda and the Milky Way, as an example, is also a product of the substantial dark matter halo surrounding the two galaxies. The dynamics of this collision, which include the eventual country of the merged galaxy, will be significantly prompted through dark matter. The new discoveries from the Andromeda galaxy have good-sized implications for how we interpret the universe. Andromeda findings offer critical facts on galaxy formation and evolution. By staring at Andromeda's structure, astronomers gain insights into how galaxies expand over billions of years. This includes the formation of spiral fingers, the increase of vital bulges, and the role of collisions and mergers in shaping galaxies. Understanding these processes in Andromeda allows astronomers to develop extra-accurate models of cosmic evolution across the universe. Andromeda findings contribute to the refinement of the universe's distance ladder. By measuring distances inside Andromeda and evaluating them with the ones from other galaxies, astronomers refine the methods used to determine cosmic scales. This is vital for estimating the expansion rate of the universe, a fundamental parameter in cosmology known as the Hubble steady. Additionally, the observe of Andromeda's stellar populace and chemical composition gives insights into the lifestyle cycles of stars and the distribution of factors across the universe. These findings assist astronomers understand the processes of nucleosynthesis and chemical enrichment that befell within the early universe and keep to arise inside galaxies. Space exploration, at the same time as advancing our expertise and era, provides environmental demanding situations. The launch of rockets, for instance, releases pollution into Earth's environment. Rocket fuels emit chemical compounds like chlorine and alumina that can harm the ozone layer and make contributions to atmospheric pollution. Debris is every other substantial difficulty. Space missions leave behind particles or area junk starting from spent rocket stages to damaged satellites. This particles orbits the Earth at excessive speeds, posing collision risks to operational spacecraft and satellites. Efforts to song and do away with space debris are ongoing, but the developing wide variety of objects in space makes this a complicated environmental challenge. On planetary surfaces, infection is a subject. Rockets journeying different planets or moons can bring Earth-borne microorganisms, risking the infection of those environments. This is specifically critical within the look for lifestyles, as added Earth lifestyles can complicate the detection of local organisms. Space missions ought to adhere to planetary safety recommendations to reduce this hazard, making sure spacecraft are sterilized and missions are carefully designed to keep away from environmental infection. Light pollution is an frequently unnoticed outcome of area activities. Satellites and large famous person clusters like those used for worldwide internet insurance mirror sunlight back to Earth, impeding astronomical observations and changing the herbal. In conclusion, the Have a Look At of the Andromeda Galaxy offers precious insights into the universe's shape, evolution, and future. By evaluating Andromeda to the Milky Way, astronomers benefit a higher knowledge of galaxy dynamics. Observing Andromeda's characteristics, together with its spiral hands and notable massive black hole activity, presents a reference factor for analyzing comparable functions inside the Milky Way. This comparative technique refines our models of cosmic dynamics and evolution. Moreover, the invention of Andromeda's length and mass challenges previous assumptions and reshapes our attitude on the Milky Way's region inside the nearby group of galaxies. Understanding Andromeda's evolution affords clues about the events that result in extensive changes in galaxy morphology. Through simulating Andromeda's modern-day status and predicting its destiny trajectory, astronomers can expect the outcomes on the Milky Way and subtle models of cosmic evolution. But area exploration additionally affords environmental demanding situations, such as pollution and infection, which must be addressed to make certain the responsible exploration and maintenance of space.